So electricity, it is one of the interesting topic and one of the difficult topic actually, and very interesting also. So if you want to study more about electronics or electricals, everything, so this is the one starting point to understand. From here, actually, those things will start. Now, without electric current, nothing works, right? Everything works because of the electric current itself. So we will now, in this chapter, we will try to study about what is a voltage, what is the current, how to measure them, what is resistance, series parallel resistance, okay, different types of the circuits. All these we try to study by this, okay. In the physics chapter, light and the electricity is the more weightage part. Okay, in other three, still 2 or 3 chapters are there. So in all the chapters, light and electricity is the one which is of more weightage part. And here light also you will get 1 5-mark question, and electricity also 1 5-mark question will come from this chapter. Mainly problems electricity will come, but once you understand theory only, it is easier to do the problems. Otherwise, you will be always end up in confusion. Once if you don't understand concept, the problems also it will be difficult to do. Once you understand, it is very easy to do the problems. Okay. So electricity. So first we have the electric current, right? So we have current. So what do you mean by a current, Aditya? Current.
The amount of charge particular.
The flow of charges, we call it as a current. The flow of charges in a particular direction, we call it as the current. So the flow of charges in a particular direction, we call it as charges. So what type of charges? In the metals, that is especially in the conductors, it is the free electrons. Okay, it is the free electrons. If they are moving in a one particular direction, we call it as current. It is the current. That means if the free electrons, if it is moving in a particular direction, then we call it as the current. Okay, consider any conductor. Conductor is what? Which one conducts the current? Correct. So that is the conductor. So all metals are conductors. All metals are conductors. Okay. So in the chemistry we studied about the atoms, right? We studied about the atoms. For example, sodium. If you take in the outermost orbit, we have 1 electron. Correct. In the outermost orbit, we had 1 electron. So what happens? These are the electrons which are easy to come out of the atom. It will not come out of the metal itself. But the valence electrons, what happens? Sometimes because of the temperature will be there, right? That is also a form of energy because it's a heat. So because of that, some electrons comes out of the atom. Okay, some electrons comes out of the atom and they will be randomly moving within the metal. They will be randomly moving within the metal. Okay, but since if you consider one piece of metal, okay, you have not applied any voltage, nothing you have done. So what happens? Electrons, free electrons will be there, just they will be randomly moving around inside the metal itself. So that will not form a current. See, some kids are there, small kids, they're randomly doing something, it will not form any work, right? Or if some parents are there or teachers are there, they are asking to do some work will be done. Like that only here, electrons will be there. See, only the protons and neutrons will never come out. Okay, always it's the only electrons which comes out. Okay, even for chemical reaction, here, everywhere it is the thing. So those electrons in the outermost orbit will be there, right? So those electrons, some electrons will come out of the metal and atom comes out of the atom, then they will be randomly moving around. Okay, those are called as free electrons. See, again I repeat, in a metal, some electrons, the outermost electrons will be there, right? So these electrons just comes out of the atoms, and they will be randomly moving within the metal itself. Those electrons we call it as free electrons. Those we call it as free electrons. Okay, so these free electrons are the one, but since they are moving very randomly, it will not constitute the current. So if you apply some voltage, voltage is the one, it is like you are applying some energy to it. Think voltage is a form of energy. Okay, so if you apply some voltage to it for some metal, okay, so what happens, it will move in a particular directions. Electrons will move in a particular directions like this. Okay, it will move in a particular direction. Think some voltage you will apply through a battery. Okay, some voltage you will apply through a battery, so they will move in one particular direction. So that forms the current. That is why in a torch bulb is there. Okay, so when you apply some when you put the battery, what happens, it will apply the voltage, it will provide a voltage, then the current will flow through it, then it constitutes a current. Okay, see again I repeat, free electrons are the one which has come out of the atom, and they will be randomly moving. So when you apply some voltage, voltage is some form of energy. Voltage is some form of energy. Because of that, these free electrons will move in a particular direction. When they move in a particular direction, they form the current. They form the current. Okay, so that is the current. And to move the free electrons in a particular direction, we have to apply some energy. That energy only we call it as voltage. That energy only we call it as voltage. Okay, then the electrons are there, right? First or second class we studied that electrons are negatively charged particles. Electrons are negatively charged particles. Negatively charged particles. Okay, and they have some charge, some negative charge is there, it has some charge. And we know that electrons are very small, that even we can't see from the eyes. So what is the charge, how we can measure that? We measure the charge in some SI unit, we call it as coulombs. We call that as coulomb. Okay, see, cloth we will measure in the meters, distance we measure in the meter, correct? Similarly, charge we measure in a unit which we call it as coulomb. Symbol used is C. Okay, symbol used is C. So what is the charge of the electron in terms of coulomb is charge of the electron. Okay, so this we call it as Q. So that is equal to 1.6 into 10 to the power of minus 19 coulombs. Charge of one electron, how much it is we consider is, that is equal to 1.6 into 10 to the power of minus 19 coulomb. That is the charge of one electron. Okay, that is the charge of one electron. Now, current, how we measure? What is the SI unit of current? How we measure the current? Lakshit, how we measure the current? Ampere. We measure the current in some SI unit. We call that as ampere. Okay, we call that as ampere. Okay, we call that as ampere. So some basic things you understood. No? So we'll write some definitions, then we'll continue.
So when you put in the battery, then this voltage applied, which direction is that across? Any particular direction?
Yeah, it is. I got. Okay, wait. I will have. Correct. It's particular direction. Hope you will not get confused. See, electrons move in this direction. Okay. See, electrons are negatively charged. So when I write the bigger line, it is positive terminal. This is the negative terminal. Okay. Actually, electrons will move from the, since they are negative charge, they attract towards the positive terminal. No. So electrons move in this direction. Protons move in the opposite direction. Protons will actually don't move. That is, we call it as holes will move. That I will tell some other time. Not everything together. But what we actually consider the direction is always opposite to the direction of the electron. But current flow direction, it is called as the conventional direction. How we, everyone will take the opposite way, so no problem, that's it. Even I don't know why they will take, but everyone, they consider electrons in which direction it will go, opposite to that. We write, whenever you are writing the direction, you will write like that. Okay, so that means we'll start from positive charge, it will go like this, it will come like this, we will write. This direction, how we write, we call it as the conventional direction. If we consider positive charge would have been moved, in which direction would have been there, like that we will consider and we will write. While writing, we will write like that. Okay. Voltage you can actually think as a some form of energy. Okay. For example, if you see in water tank, we will from the sump, we will load the water to the water tank. Correct? We will load the water to the water tank. And then if you just leave the tap, water will come from the overhead tank to here. Why it will come? There is some difference in the height. Correct? So difference in the height, and water would have obtained the potential energy. Correct? Water would have obtained the potential energy. So that because of that, that is converted into kinetic energy and water will flow. Like that only, think here, voltage is a form of energy. Because of that, electrons are moving in one particular direction. Okay. First one, electric charge. Charge is a physical entity which is defined by excess or deficiency of electrons on a body. SI unit of charge is coulombs. Charge of the one electron. Charge of one electron is equal to 1.6 into 10 to the power of minus 19 coulombs. Next, charge of the one proton is equal to, here electron is minus, proton is plus. 1.6 into 10 to the power of minus 19 coulombs. They are equal charge. Proton and electron, they will equal charge. Electron will have negative, proton will have positive. So, okay. The charge of 1 coulomb is equal to charge contained by 6 into 10 to the power of 18 electrons. Okay, see, we know that coulomb is the unit what we use for the charge. Okay, and electron, it's very small. Its charge is equal to it is minus, since it is negative 1.6 into 10 to the power of minus 19 coulombs. So if I collect 1.6 into 10 to the power of 18 electrons together, if you add all the charges of each electron, that will be equal to 1 coulomb. Okay, if I collect 6 into 10 to the power of 18, so many electrons together and keep one side. So, if you add all the charges of all these together, that will be equivalent to 1 coulomb. That is the unit what we consider. Okay. Electric current. It is defined as the rate of flow of electric charge through any cross section it is defined as the rate of flow of electric charge through any cross section of a conductor per unit time or in unit time. Okay, so current we indicate as I. Current, the symbol we use is I, that is charge per time. So that is N into, write down N into E by T. N into E by T. So what does it mean? Means, see, any cross section means if you just cut, we'll have that circle, right? That is the cross section. If I consider some cross section, some point, okay. So when wire is there, if I cut one cross sectional area, I will get that. So how many? What is the total charges will flow through it per unit time? Always we consider per second. So for 1 second, how many total charges in terms of coulomb? How much it will flow through that? That we call it as current. Okay. So what will be the net charge? How much you can find? Number of electrons that flow into its charge. That is the total charge value per unit time. If you consider, then we call it as current. Okay, again I repeat, see, cross-sectional area means, see, one wire is there, if I cut that wire, it will be some circle will be there. That is the area of that. So, how many total amount of charge will pass through it for one particular unit of time? That we call it as current. Okay, so what is the total charge amount? How you will calculate? The electron charge is 1.6 into 10 to the power of minus 19 into number of electrons. That will give you total charge for how much time it will pass through. So then that we call it as current. Usually the time will be in seconds we consider. Okay. Q, yeah. Huh? N into E is Q. E is charge. See, E is the charge of each electron. Okay, and N is the number of electrons. So Q will be equal to the total charge here. Total charge will be equal to Charge of each electron is 1.6 into 10 to the power of minus 19, right? That into number of electrons. Okay, that's what I mean. If you want to write a note, charge will be equal to Q is equal to M into E. Next comes the SI unit of electric current. Right? Okay. SI unit, the SI unit of electric current is ampere. Okay, it is ampere. PE ampere. PH only it's there. Okay. ER only there. Okay. Anyway, just the spelling, it's fine. Okay. Ampere. A is the symbol. Okay. And it is a scalar quantity. It is a scalar quantity. Scalar quantity, that means when we are doing addition or subtraction, we don't do vector addition then. We do the normal addition. That is, we will not consider how with the angle there. That is the meaning actually. Okay, scalar quantity, another way to tell is it has the magnitude and it does not have the direction. Okay, that one. And 1 ampere. Okay, so now how we will define 1 ampere? So write down 1 ampere is equal to 1 coulomb by 1 second. Okay, 1 coulomb by 1 second. That is, if 1 coulomb of charge, charge flows through the cross-sectional area, flows through any cross-sectional area, of a conductor in 1 second. Then the electric current is said to be 1 ampere. Okay. That means, see, there is one conductor, one wire is there. Okay. In that, for 1 second, total 1 coulomb of charge will pass through that for 1 second. Then we call it as 1 ampere of current. Okay. So if I take one cross-sectional area here, for 1 second, 1 coulomb of charge, total charge will be equal to 1 coulomb if it is flows through that. Then it is considered as 1 ampere. So, and we know that 1 coulomb will be how many electrons? It is, we studied the 6 into 10 to the power of 18 electrons. So, coulomb, it's a bigger unit. Okay. So, ampere now also will be a bigger unit. Since coulomb is only a bigger unit, 1 ampere is a bigger unit. So, we have also the smaller units like microampere, milliamperes, picoamperes. Okay. So, smaller units are used. Actually, ampere is a bigger unit. Okay. So, we use smaller units of current also. Smaller units of current. First one, we call it as milliampere. Okay, so this we will write it as this. So 1 milliamp is equal to 10 to the power of minus 3 amps. Okay, another one, microampere. Mu, we'll write like this, mu amps. 1 microampere is equal to 10 to the power of minus 6 ampere. Milli is like milliampere and ampere is like grams and kg. Correct? So if you want to write kg in terms of grams, we'll write 1000 grams. Or 1 gram is equal to 10 to the power of minus 3 kg. Correct? Same thing. Here also, we have smaller units. Okay, so one is the milliampere, milli symbol m, small m. Okay, milliampere, that is equal to 10 to the power of minus 3 ampere. Another one is the microampere. Micro is 10 to the power of minus 6 ampere. Next comes the direction of the current. Direction of the electric current. Okay. The direction of the electric current, the direction of the electric current is taken as opposite to the direction of the flow of electrons. This is called as conventional direction. Okay, listen here. Actually, if you consider one wire like this, okay, if I apply a voltage by a battery, this is positive terminal, this is negative terminal. So free electrons actually gets attracted towards the positive terminal, and okay, it will flow like this. It will be flowing like this. Okay, but when we will write the direction of the current opposite to the flow of current, opposite to the flow of electrons. Okay, but when we write the direction of the current, we will write opposite to the direction of the electrons. So we will write like this. So always simple way. If you get confused, just remember from negative terminal you should write the current. So it starts, it will flow like this, it will come like this. Everyone is writing the opposite way, no problem. That's it. Okay, that's how in every place we will write like that. That we will call it as conventional direction. Okay. So write current is equal to Q by T, that is total charge per unit time. That one. I think you have written Q by T. Okay. Read once whatever and all we studied, then we'll do some problems. Here we will end today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.